Hello, thank you everyone for joining this call. Welcome to my channel, Googleads. In today's sessions, what I'm planning to do is talk about the Kubernetes Ingress. If you are not familiar with the Kubernetes Ingress process, or what is Kubernetes Ingress, I will talk about this Kubernetes Ingress in today's sessions. So we'll cover these topics. What is Ingress? Why do we need Ingress? What problem is trying to resolve, right? And how Ingress object work. Apart from that, we will also talk about Ingress controller, which is required because there is no default controller to process the Ingress rules. And we'll also talk about different types of Ingress controller like Nginx, Kong, and those kind of stuff. Just a brief introduction on those Ingress controller. So that's the plan. If you have any questions or concerns or anything, basically just comment on the chat box below or in the YouTube streaming, and I'll start answering those. I'll keep monitoring here. This is the first time I'm talking in English in this channel. So if you're having trouble understanding my accent, possibly just keep, I'll try to speak slowly actually. I mean, I cannot speak fast as well, which is fine. All right, so let's start with the Kubernetes Ingress, right? So what is Kubernetes Ingress? Simply speaking, Kubernetes Ingress is a router. So you can think this as a physical routers where it receives the initial calls or initial requests and respond something by processing that one. So you can think as a, let's say, reverse proxy or virtual host in terms of Apache, where you are sending requests www. Let's say googleice.dev. By the way, this is our community, so if you want to join this community, feel free to join. Actually, it's W missing here, so which is fine. So this is our IT community. If you want to join, you can join this and then comment and those kind of stuff here, or write a blog. And if you want to read the blog, that's also fine. All right. So, anyways, so Ingress controller is basically acting as a routers and which send traffic to Kubernetes service. So what is Kubernetes service? It's a logical layer. It's a collection of multiple pods, and pod is collection of multiple containers, right? So that's how it works. I'll explain that in a pictures view later. So when you create an ingress, you basically, and there are multiple ways you can create the ingress rules. So you can say, for example, one example is you can say www.googleice.dev. That's one example, right? So another example could be, let's say, www.googleice.dev or .com/ and if you do blog, so it's going to our ghost blog. So this is another example. So this is called context-based, where you are passing the path/path. And the first one is just like if you remove this one, it's going to some Ingress control as well. And this is your domain name or subdomain base as well, right? So if you do, let's say another example is Waknepa, right? So all of these actually serve using same Ingress controller. These are all the production grade deployed applications which is running in the production. But if you try to resolve all of this, so let me show you one example here, and let's look up www.example.com. It's resolving to this IP address 174.51.172.239, right? So all of these domain names are pointed to this address. You can do same for, let's say, NS lookup, and then you can do, let's say, www.googleice.dev. Again, it will return the same IP here. So this is my Ingress IP address. So this is my static public IP pointed to Ingress controllers. So same is valid for www.googleice.dev. And these are all pointed to same IP address. So the way it works is when you send requests to this DNS name goes to this IP address. I mean, pointed to this IP address as a record set. And as soon as it relates to that controller or the load balancers, in this case, Ingress controller, Nginx Ingress controller, I'm using it. It will understand these particular rules. It says, okay, this request is coming from www.waknepal.com. Let me send this particular traffic to some applications because I have the rule and I understand that rules, right? So similarly, if you do, let's say, curl, and then I mean, we cannot resolve that. So, but let's say curl to www.googleice.com com slash, let's say, blog. And it goes to another application because it also understands the context base. So if you say slash something and you have that English rules, it will basically send traffic to that particular application. In this case, this slash blog is serving Ghost blog. And even if it's there are two applications, vlog is Ghost blog, which is community supported blogging platform, and www.googleites.com is Java based web applications, right? So both are served using same English controller, and based on the traffic or based on the rules, the English controller send the traffic to particular applications. So that's how English controller actually works in real life. I've also used the another features. You can actually use English controller or English rules, I mean both combinations, to apply the certificates here. So I'm using Let's Encrypt to automate that certificate process also, which I'm not going to cover in this session, but in future sessions maybe I'll try to cover that one as well. So this is the basic purpose of English rules and English controllers, which act like routers, sit in front of or act like a load balancers, understand the rules, where the traffic is coming from, and send the request to that particular applications. That's how, or that's the purpose of English controller and English rules, right? All right, so here is the basic examples of English rules. So the way it works is, let's say we have one simple applications, pod. So this is the pod, and it's running the one container HashiCorp slash HTTP echo. This is a very lightweight applications, which basically echoes some text here. Text equal to googleites dash foo, right? So that's the text I'm trying to pin from these echo containers, and I'm trying to run this pod. So let's try to create this pod. You can simply say OC apply -f, and then paste that content here, and then do basically apply that one, right? So now if you do get parts, I'm running this applications, which is running like 4 seconds ago, and it has the, let's say, IP address 10.244 something, and it's running in the kind-worker 2. Now, if I want to access this application using a service object, I have to create rules like this one. So just notice these labels app-foo should match with your selectors. Otherwise, this service will not able to find that part applications. But part. Now let's apply that application here. I can simply say apply -f, and then just create the service object, right? So here, now it's just applied the service object. Now if you do get svc, we have this service object googleites dash foo dash service, which has the cluster IP, this one. Now if you want to access this, I cannot use this cluster IP. This is just the Calico IP assigned to cluster service object, and it's only resolved inside the Kubernetes cluster. So you cannot access this outside the Kubernetes cluster. I mean, there is a way to advertise this one if you want to, let's say, use BGP routes, or if you want to add Linux route manually, you can do that, and then you can also reach to this one from your local machine as well. But that's not the proposed here. So this is just think this as a private IP address resolving inside the Kubernetes cluster only. So you cannot resolve this outside the Kubernetes cluster, right? Now, if you want to test it, you can simply run another container. So let's say I can run like nginx, and then say image is nginx here, right? And this will create the pod nginx. I can connect to this. Let me run one more time. This is still running this. It's creating the containers, possibly downloading the images, setting up network, and those kind of stuff. So now the container is running. So what I can do is attach to these containers, and I'm inside the container now. You can see root @nginx here. I'm inside the containers. Now you can do basically curl to this IP address 5678, and it should return googleites dash foo, right? Or you can also use service name here, curl, and the 5678, and this should return the same response as well. Now both are, and this is the way actually normally Kubernetes pod and the service object work inside the cluster. So we basically create the cluster IP type, and we can create this service, and then from the service, if you wants to call another foo service, let's say foo or bar service from this foo service, from these four applications, you can technically say googlex-bar-service as an example, and reach out to that bar service from the foo service, or foo applications. That's how Kubernetes service object work, right? But if you want to do an ingress controller, so you can see like this is the ingress rules I'm talking about before. So here, this a part should match with the service. Now what we can do is create the ingress rule like that, and just notice this service name googlex-foo service should be on your backend here. So what I'm trying to do here is create a foo.googlex.local. This is a host name. We'll create this host into later. And I'm saying /foo, and this is basically pointing to this particular service. So when you send the request to this ingress rules or this DNS name at context /foo, it will basically send traffic to this service object here, googlex-foo service, at the port 5678. Of course, this is running at 5678. And this will eventually send traffic to the pod. That's how it works, right? So I'm trying to explain this using these two examples as well. Currently, we have created only one applications. All right, before that, let's test this one, and then we'll explain that the multiple application scenario as well. So first of all, let me create this ingress rule. This is a very big ingress rule, basic ingress rule. Let me apply that one. kubectl get ingress. You can say ing as well. So here I just created one rule, which is say foo.googlex.local. When you send traffic to foo.googlex.local, send a request to service object. It's called googlex-foo service, and that's the service we're testing before, googlex-foo service, at port 5678, and this is how we're testing it. And when you send this request to service object, it will send a request to pod automatically, right? So that's how ingress rules work. Now the problem is currently we don't have ingress controller, and that's Kubernetes limitation. It does not provide this ingress controller. It does provide a controller or kube controller for deployment object, pod object, or even service object, but it does not have ingress controller. So you have to deploy that ingress controller, and there are various ingress controller. For example, Kong. You can also use STO. There is Linkerd. You can also use HA proxy, and in this case, I'm trying to use Nginx ingress controller. So I will use that Nginx ingress controller to deploy that controller and then browse this application from my browsers. So that's the goal right now. So let's see. For example, first test this whether we can resolve this or not, right? So let's see, curl to this and then do, what is the rule I created? Foo, right? So let's see if I can raise to this one. So for now, I cannot raise. I mean, I'm not sure if it is related to that. So let's see if I can. I'm resolving properly or not. I'm not even resolving properly. So not sure what is this address, right? So it's not able to resolve the host. So in this case, it's not even processing this. So even Kubernetes is not able to process it at the moment. So there is no record set for this particular record set. For this in this name server 1096.0.10. This is our kubedns or CoreDNS address in this case. So let me create one ingress controllers here. So what we can do is we can deploy the ingress controller. I have created another slide for that one. I'm using Kind, by the way. So this is 3-node Kind clusters. Now this is the ingress controller. So I took this from this Kind documentation itself. So this is not the one I created. So I'm going to simply apply that one. And this is, I mean, there are a lot of definition or object in this deployment object here. So you can see I have just created namespace ingress nginx. I have created service account for this one, and for the nginx and admission controller. There is RBAC rule for that one. We have also created cluster roles, cluster role bindings, and there is a config map. We have also created service object for this ingress controller, and then we have deployment objects, jobs, and other stuffs, right? So let's see if the controller is properly working or not. So it looks like it's still trying to deploy. I can see the admission controller or the job is already applied, or at least I can see one reboot for this one. Possibly this is trying to do some kind of patch in this one, which is not running at the moment, and eventually it will run. So you can already see this is running now. So it's create the containers, but the health check is not passing at the moment. Now health check is also passing, right? Now, since I deployed the controller and there is an ingress rule already available, so let's see what happened here. So technically now, and you can see this is already assigning the IP address localhost. I don't think I can use this localhost at the moment. So let's see. This is odd actually, which is strange. So looks like I can use localhost to browse this one. So what I can do is, I wonder if this is already set up. All right, so let me do one thing. Echo 127.0.0.1 and create this entry here to etc host. Right, so let me append it so that I will not overwrite accidentally. Need to be sudo. Let's do that here. Okay, so now this is added. Let's see. This is foo. Actually, let me do another for foo.google.local as well. Oh, that's interesting actually. It's saved now. So what I'm going to do is let's add that record sheet here. 127.0.0.1. Let's see if I can reach out to these applications. Curl to that one. All right, so somehow I think it's responding. Something else is responding. I didn't think this is my applications. Maybe it is my application because it requires bar as well, right? Or maybe foo. Or actually it requires foo. Google, always this DNS is not global one, it's public one. So there you go. So it's actually, I can now reach to that particular address foo from my browser as well. So that's how Ingress controller work, right? So yeah, it's already, and then the Ingress controller actually already deployed. I saw that before. Let's see. Sorry about that. I don't know what I'm doing. CoolCTL get parse, and then let's do Ingress and the next, I guess. All right, so everything is running. So the way it works is we do have one service object in this namespace, Ingress Nginx, and we're sending request to this one first. You can technically create this, and there is no external IP. Actually, it's supposed to be exposed as a node port. I mean, currently we're using node port and we're using localhost, so somehow kind is creating this address. But technically, you have to create this object as a load balancer, assign this IP address, and point this IP address to your DNS intercept. That's how it works. Currently, we're using 127.0.0.1 because there is no external controller which create the load balancers type, at least in my local machines. So that's the reason I'm using 127 or loopback address. But here, if you deploy these clusters in, let's say, AWS Cloud or Google Cloud, you can technically use this external IP address here. All right, so that's how it works. Let's move on. So now let's move on using another example. So let's consider two applications. One is web application 1, another is web application 2. You can see these are all blue. And this we're trying to browsing using webapp1.example.com, and there is another application web.example.com/app, right? So we can test like both ways. So we can use subdomain approach or DNS approach, FQDN approach, and then we can also test using context-based route as well. So here, this is the one application deployed. And another application is red, which is webapp2.example.com, and you can also test using /app2. That's the way you can test it. So that way you can use the same DNS name, and if you want to route traffic based on the context, you can do that. So here we're using webexample.com, which is not the case with the subdomain. In some cases, you may want to do that, right? So here, the typical way you manage is like, let's say you create a deployment object. Deployment object create the replica sets. That's how Kubernetes works. and replica set create the parts object, right? So, and then part create the multiple containers if there's any if there are multiple container inside this part basically. So that's how it works, and then everything is based on the level selectors only. Now, if you are not using, let's say, service object, the typical way you do in Kubernetes is you basically create. If you're not using Ingress, you basically create the multiple service object. So here we are creating like service. Let's call it like web app dash service, and then possibly this is one hypothetical IP address, but it will assign the unique IP address for that service object. And we have another service object, web app 2 dash service, and then you are also assigning, or Kubernetes will assign some IP address, random IP address to this one. Let's say in this case 1096.0.30, and this level selector should match with this blue applications, and this level selector for the red should match with the red applications, right? And if you want to access this application and this application from the in user point, then what you need to do is create the load balancer service type, or assign some external IP address to this service object, and you create the DNS interset. It can be context-based routing, or you can directly create the subdomain-based area code set as well. And you can, and this is on your DNS site, right? So that's the normal workflow without Ingress controller or Ingress rules. But the problem with this approach is this load balancer are costly operations. If you have like, let's say 100 different services, then 100 different applications deployed in that clusters, and all of them you want to access from outside the clusters, then you have to keep creating load balancers for that operation as well. So which can be costly, and you may want to avoid that. So let's say you are running in some kind of AWS or some kind of cloud, let's say example AWS, and you are creating load balancer type, then it will keep creating ELB, or you have to create ALB, application load balancers, to send the traffic from your DNS request set load balancers to your applications. And that's a very costly operation. So instead of doing that, what you can do is, like if you compare this one with the Ingress process, again, same picture. So we have applications, deployment object here, we have selectors, and then we have service object here, right? Same, there is no difference. At least we remove these pictures, but there is no difference on your right hand side of these pictures, right? Now what you can do is you can create the Ingress rule, which we did in our example as well. In that like foo.goglash.local, in this example we did that, right? So we created the Ingress rule. But the problem with the Kubernetes is there is no controller which understands this Ingress rule. So if you create the service object, there is a controller which understands that. If you create the deployment object, there is a controller which understands that configurations. Or if you create the like replica set, there is a controller which understands that one. And all of them is like Kubernetes controller job, right? But there is no controller which understands the Ingress rules. And what you need to do is create the Ingress controller on your own, like the manually. And that's what we did. We applied that Ingress controller. So you have to create the Ingress controller, and this is the case we did. We created the Ingress Nginx Ingress controller. We deployed that one, and it will start understanding this Ingress rule. Now, based on these rules, it actually, let's say some users, and you have to expose this Ingress service, Ingress controller. So entry point is always like that. So Ingress controller, you can expose a load balancer and create the DNS interset here. So this DNS pointed to your load balancer of the Ingress service object, right? And this Ingress service object send the traffic to this Ingress controller. This Ingress controller understand these rules and say, okay, this request is coming from this blue applications. Let's send this traffic to this particular set of applications. So that's how Ingress controller work. And that's how Ingress rule is being processed. And this is the reason we need Ingress controller, because without this Ingress controller, you cannot, or there is no applications or which is processing these rules, and there is no effect on these Ingress rules at all. So be careful, you have to deploy this Ingress controller, and you have to choose that early. So that's how it works. And I think that's my plan for today. So there is nothing more I'm planning to cover. So if you have any questions, concerns, or anything, basically, you can ask questions in this YouTube channel itself in the comment box below. I'll publish this video as soon as the streaming is complete. Or you can also ask the questions in goglash.dev. This is our community forum where you can ask anything related to Kubernetes or even DevOps or anything, basically IT related questions you can ask here, and I'll try to answer that as soon as possible. So having said that, let's conclude these sessions. I'll see you in next sessions. Thank you. Let me end the streaming. Come on.